3 or 4 years ago now regarding the perfluorocarbon liquids and why their chemistry is important for clinicians to understand.
Great, thank you, Johnny. So I'm going to start this talk. This whole symposium actually came about because of this original problem that I think most of you probably in the room are aware of. But I'm going to, given that you're all probably aware of this, I'm going to ask you a question, a quick sort of warm-up, stick your hands up. How many of you, first of all, know the manufacturer of the heavy liquid that you use? Can you stick your hands up? Who actually knows what they use? It's not a great show of hands, if I'm going to be honest. And then if I ask you, of the 10 of you that put your hands up, do you actually have any idea what measures of purity we look for when we're going to our pharmacist to go and buy that heavy liquid or that oil? Yeah, so there's one in the front row and she's talking. So the point being is that very few of us as clinicians have any idea what the stuff is that we're putting into the eye. So anyway, the reason that's important is as follows. So this comes with the usual disclosures. Most of us have come courtesy of Dork, thank you very much. And we all went on a lovely visit to see what Helge does in PharmPure. That was great. And I can't tell you, this is all borrowed knowledge. I am not an expert on heavy liquids, but so a lot of my these slides have come with help of the following people. So I've asked you what you use and how we assess purity and what measures of toxicity are you aware of. And of course, we are talking about these episodes that started to come to light in 2013, 2015. And it came out of 3 main companies, and that probably represented the tip of an iceberg. And so there were over 150 cases and spread as far, the greatest number of cases were in Spain, but as far afield as Chile, Switzerland, the Middle East. And what was happening? Well, here are a series of routine cases that you and I would all do and expect pretty ordinary outcomes. Visual acuity is there that you can see all as you would expect, surgery that you would expect, but using heavy liquids as a short-term tamponade during surgery. And the outcomes, no light perception, certainly outcomes that none of us would have expected. Atrophy, rubeosis. Here's what it looks like immediately, exposure, acute retinitis intraoperatively, and 2 weeks down the line, massive thinning of the retina. How can this happen? All these products that we are using are supposedly CE marked. They conform to the ISO standards of the time. And we hadn't had any cases as far as we were aware during the 90s and the 2000s. And really understanding this is all about understanding how these products are made. So initially, perfluorocarbon liquids were produced as a byproduct of massive production of Teflon and Gore-Tex by these huge companies, huge chemical companies like 3M and DuPont. But actually it became aware that a certain substance, PFO, perfluorooctanoic acid, was probably responsible for a very significant increase in renal carcinomas, liver carcinomas. And so these companies stopped making Teflon. And therefore it began to fall to smaller companies who didn't have such enormous expertise in producing really clean, high-grade substances. And so it was probably falling to these smaller companies to make them. So we're indebted to Jose Pastor and latterly Mario Romano and the Mentz group for identifying what these substances were. So Jose Pastor has a direct contact method, and he identified in those original Alamedics batches PFOA, perfluorooctanoic acid, and DFH and benzene, and subsequently hydrogen fluoride in very large amounts. And so we have 2 main techniques that are being identified, a chemical analysis or a direct contact with AR-RPE cell lines, 2 different mechanisms for detecting toxicity. Now, of course, as VR surgeons, as medics, we are drawn to the biological. We like the concept of putting a substance on top of a cell line, and if it's toxic, we understand that. But of course, the problem is you've got to define what toxicity is. And so classically, toxicity in these cell line experiments is defined as 30% cell death. So that means that we have to be happy with 29% being okay. And that is potentially a bit problematic. So the Mentz group have done a complete chemical analysis to identify all of the various impurities that one finds in the heavy liquids that we use. And they've classified them according to the mechanism of action. So we have class 1, which you can see is reactive underfluorinated compounds. And that's because the perfluorocarbon liquid, if it, they introduced the concept of an H value. An H value essentially is the proportion of that carbon backbone that is not fully fluorinated. And if it's not fully fluorinated, there is the potential for reactive species to attach to that point and become toxic. And so class 1 were the byproducts of PFCL synthesis, and we can use H value as an analytical tool. There are things like surface active compounds, which are hydrophilic, and that means that they have the potential to penetrate tissues, so they're potentially a lot more harmful. And then what they call class 5 contaminants, which are related, manufacturing-related compounds, so things that are made during the manufacturing process. And when you then look at the different chemical compounds that were found to be toxic, they fall into these different groups. And you note that class 4 has no cause of toxicity at all. So DRESP then in 2021 went and looked at a wide variety of we're running out of time. A wide variety of available products and identified in those a substantial number that had high H values, and we could buy those on the market. Decalin, interestingly, has a more circular structure, so much more difficult to have to have not fully fluorinated. That ring structure basically prevents it gives you a much lower H value. So Mario Miramano, just to wrap up, has also contended, however, that H value on its own is not necessarily predictive of whether something is going to be toxic, and they showed something with compounds with a very high H value but not so cytotoxic, and that just shows that there are obviously other elements that go into the manufacturing protocols that can be cytotoxic. So we now have, as Helge mentioned, a new ISO standard which identifies that as long as we're using these different detection techniques, either looking at cell lines or very high spec manufacturing processes, then we should be more confident in the process of manufacturing. I'm going to mention very briefly, because it is important, that remembering that the high vapor pressure of PFO, and so if you have a large retinectomy and there is exposure of the vortex ampulla to perfluorooctane, that can have fatal consequence, and Mario Antonio is going to tell us a little bit more about that potentially. So I'm going to wrap up there, but just to say that the system has changed now, so there should be more faith in the system, and toxicity measuring is now done a lot more competently than it was. So we should all have a little bit more faith in the choices that we make. Thank you very much.
Thank you, Rob. Please feel free to come and sit down, guys, if there's plenty of space.